Hello everyone, welcome back to another GIS mathematics lecture video. And in this lecture video, we're going to come back to this idea of the indirect distance, indirect height, and we're going to go through two examples. Before we do that, I just want to quickly recap the idea that generally we have some angle that we are given, and we have either a height or a distance that we are given as well, and that we're going to use tangent to derive some equation to figure out that either distance or height depending on what you look at. So if this sort of setup does not make sense to you, I encourage you to go back to the previous video where we walked through conceptually how to get to tangent and then come back and watch this. Otherwise, let's go ahead and get into some examples. So the first example, you have a 12-foot ladder which forms a 33-degree angle with the top of the wall. How far away is the base of the ladder from the base of the wall? I find it is always really helpful to diagram things out. So we have ourselves a wall here. Doesn't have to be a good diagram, but it helps to have a diagram. So we have a wall here. We have a ladder here. Let's try and make that a little bit more straight. We have a ladder here. I don't know if that's any better, right? And we know that the ladder height, we know that this is 12 feet, right? Because it's a 12-foot ladder. We also know that this angle here is 33 degrees, right? Because we have a 33-degree angle with the top of the wall. So the question is asking how far away is the base of the ladder from the base of the wall? So this is the base of the ladder right here. This is the base of the wall right here. So we're asking ourselves, what is this distance right here? Okay. So now what I want to do is I want to go back through conceptually what we have and what we want. So we have this angle 33. So we have the 33. So if we have this, if we were to take the sine of 33, what would that relate? Well, sine is so it's opposite over hypotenuse. All right, well, let's look at this equation. Let's look at what we have. So this is our right angle, right? We're assuming that everything is flush and that we don't have any weird errors here. So our hypotenuse, or our opposite angle, right? Opposite is the angle that is not touching. Or, sorry. Opposite side is the side that is not touching the angle. So in this case, right, the opposite side of 33 is in fact our D. And the hypotenuse is always the side opposite the 90-degree angle, which is our 12. Right, so actually first try, right, we got our unknown here, and our known here, and our known here. So we're actually not going to be using tangent in this case. In this case, we're going to be using sine. So we would say the sine of 33 degrees is going to be equal to D, which is the distance from the base of the wall to the base of the ladder, divided by the hypotenuse, which we said was 12 feet. Okay? So now we can rearrange this equation to solve for D by saying that D is going to be equal to 12 feet times the sine of 33 degrees. So now we're going to do that multiplication. Again, I don't know what the sine of 33 degrees is off the top of my head. We can pull out our scientific calculator here. We can clear what we were working on before. And we can do the 33. That's this angle here. Make sure that our scientific thing is in degrees. Select trigonometry and go to sine. So just to sort of keep track of it, that's 0.5. Of course, it's not going to stay up at the same time. It's going to be 0.545. So that's approximately 0.545. And if we multiply that by 12, which is the length of our ladder, we're going to get approximately 6.5 feet. So that's going to be D is going to be equal to, again, approximately 6.5 feet. So hopefully that makes sense. Let's go ahead. Well, actually, before we go any farther, take a second, make sure you understand all the steps, understand why we used sine in this case instead of tangent, which we talked about before. And let's go ahead and look at another example. So if you need to take a second, pause the video. Otherwise, let's go on and look at another example. Okay, so in this video, or in this example, right, we're standing 50 feet, so we're going to need to remember 50 feet, from a tree looking up at the top. The angle between your line of sight and the ground is 55 degrees. How tall is the tree? So let's go ahead, and again, I find it's always really helpful to sketch out our problem. So we have a tree here. Just to make things a little different, let's make it a pine tree. The problem didn't specify, I'm taking creative liberties here. We have a pine tree. And we as a person are standing 50 feet away. So this is us as a person. We are standing 50 feet away. All right, 50 feet away. We're looking at the top of the tree, right? And the angle between our line of sight, which is this line here, and the ground, which is this line here, is 55 degrees. So we know this angle right here is going to be 55 degrees. Okay, so we've taken all the information and we've sketched out the problem. So let's take a look and see what we can do about this. So we have this angle here of 55 degrees, and we have this known here, and what we want to know is the height of the tree. This is going to be our h. So I'm going to skip going through all the different options. I'm going to say we have an angle, we want the opposite, and we have the adjacent. So what relates opposite to adjacent? Right, that's tangent, right? Tangent is TOA, so it's opposite over adjacent, right? So we have the tangent of 55 degrees is going to be equal to the opposite is our h, right? That's the height that we want, divided by our distance from the object, which is, again, 50. So to isolate for h, we multiply both sides by 50. So we say h is equal to the tangent of 55 degrees times 50 feet. Now I'm going to tell you right now this is going to be an alarmingly large tree, but let's go ahead and just do the math here. Again, I don't know what the tangent of 55 is, so I'm going to pull out my calculator. And we're going to type in 55, and then we're going to go to trigonometry and tangent. And of course it goes away before I can write it down. 1.43 approximately. So this is approximately 1.43 times 50. So I can tell you just ballpark, this is going to be approximately 75 feet. But let's go ahead and do the actual math here. So we're going to take our tangent from before, going to multiply it by 50. Oops, I want trigonometric functions. I want the actual answer. There we go, 71.4 feet. So hopefully that made sense. You can see that in this case we used tangent because we had the adjacent and we wanted the opposite, versus in this example here where we had rotated things around a little bit. Right, we had the hypotenuse and we wanted the opposite. So hopefully that makes sense why we chose those two different relationships. If any of this was confusing, Please watch the video again. Think about the relationships with SOHCAHTOA. And as always, please reach out. Thank you.